Hey everybody. So today we are going to move on and try some different techniques for solving quadratic equations. And now, just a bit of a recap. A quadratic equation is anything that's got x squared in it. So it could be something like x squared plus x minus 1. Could be 3x squared minus 4 equals 0. Technically, they should equal something, but that it's just a x to the power 2 equation. So we're going to go through a couple of different techniques for factoring or solving these, and then I'm going to go through what's called completing the square. So we've got the equation x squared minus 25 equals 0. And now this is what you'd call a difference of squares, and that's because there is a perfect square on the left and a perfect square on the right. Every term is a perfect square. So we can use a trick to factor this. We can use the conjugate trick. And we can say x minus 5 times x plus 5 equals 0, because x minus 5 and x plus 5 are conjugates. So if we factor it, whatever makes the brackets equal 0 is a solution. So x equals 5 would make the first set of bracket 0, and x equals negative 5 would make the second set of brackets 0. So those are our two solutions. We're going to solve the same one slightly differently, though, by using square roots. We're going to move the 25 to the other side by adding it to both sides. So x squared equals positive 25. Then we're going to take the square root of both sides. X equals root 25. And now root 25, x is going to be plus or minus 5. And we get exactly the same answer either way. If we remember to use both the positive and negative root of, well, just positive and negative root, we can solve the equation using the square root, and it will save us a little bit of time, sometimes. So let's take a look at another one. This is one that's not a nice difference of squares, and it's going to be kind of ugly for us to deal with. However, we can solve it using square roots relatively easily. We're going to do BEDMAS, but we're going to do it backwards. So we're going to deal with, well, it's SAM-DEB, subtraction and addition first, then division and multiplication. So for subtraction and addition, we can move the 1 by adding it. So x squared over 3 is going to equal 12. Then we can deal with our multiplication and division. We can multiply 3 away to both, or multiply 3 to both sides to get rid of it. X squared equals 36. At this point, we can take the square root of both sides to solve for x. The square root of x squared is just x equals the square root of 36. And we'll see that x equals plus or minus 6 is our answer. That would have been quite ugly to try to factor because we'd have a leading coefficient that's not 1. This next one's going to give us another example of when it's going to be easier for us to solve using a square root. So x minus 3 squared equals 25. It's already arranged for us in a way that we can just square root both sides. X minus 3 equals the square root of 25. And now we've got to be really cautious because we have to do both the plus and the minus of the square root. So technically x minus 3 is going to equal plus or minus 5. So let's actually split this up. Let's split it up into the case where it's going to equal plus 5, and we'll split it up into the case where it's going to equal minus 5. And we'll get two answers. X minus 3 equals plus 5. We can move the 3 to the other side by adding it, and x will equal 8. That will be one of our answers. If we do minus 5, x minus 3 equals negative 5. When we add 3 to both sides, we will get x equals negative 2. We need to account for both of these or we will be missing one of our solutions. Okay, what if the equation doesn't have a perfect square? We may need to do what's called completing the square. So we may need to complete the square before introducing a square root to solve. Remember, to find a value, to add and subtract, in order to add it, we have to add to both sides. So to find a value to add or subtract, we are going to add or subtract the same number from both sides. So when you're completing the square, it's this idea that you want to create something perfect like x minus 3 squared. Some will work out like this, some will not. So like, for example, you could take x squared plus 4x plus 4. That could be factored into just x plus 2 squared. It's just x plus 2 times x plus 2. Some equations will work nicely like this. Some equations, however, won't. You could get something like x squared minus x plus 17. That is not going to factor nicely into x plus 7 or something like that. That's not going to work. So we need to add something strategically to both sides of the equation so that we get a perfect square. And there's a trick to this. So if you have ax squared plus bx plus c equals 0, and you want to create a perfect square trinomial, you move the c to the other side. Ax squared plus bx equals, I guess, negative c, but we can ignore that. And we need to add something to both sides. Now the something, if you take b and you divide it by 2, and then you square it, that is going to be what you add to both sides. And you've got to do it this way because it will always work. It's going to seem kind of weird the first time you do it, but the reason for it is pretty sound. It's because when you go to FOIL your brackets out, you're going to be doubling your middle term, which is why we're dividing our middle term by 2 to figure out what to add as our final term. So let's walk through an example of this. Let's do a question. X squared minus 10x equals negative 16. First thing we need to do is we need to figure out what to add to turn the left side into a perfect square trinomial. In this question, b is negative 10, or b is, we can just say b is 10. So we can take this 10 and we can divide it by 2 and we can square it. 10 over 2 squared equals 5 squared, which equals 25. Okay, so if we add 25 to both sides, we can turn this into a perfect square trinomial. So let's do that. I'm going to start by just writing the equation at the top. X squared minus 10x equals negative 16. But I'm going to add my 25, and I'll do that in a different color just so it stands out. Plus 25 plus 25. That number came from taking b over 2 and squaring it. Now I have a perfect square trinomial on the left. This will factor into x minus 5 squared. I know it's minus 5 because the middle term is negative 10. If it was plus 5, it would be plus 10. And the right-hand side is going to, well, 25 minus 16 leaves us with 7. Or sorry, leaves us with 9. So now we can go ahead and we can finish solving this. We can square root both sides. X minus 5 equals 3, which is the square root of 9. We can add 5 to both sides. X equals 8. And we're done. So this is going to seem kind of weird for the first few times you do it, and that is because we're using this completing the square trick. So what do we do if the leading coefficient is not 1? It's going to be a little bit trickier for us because in order to deal with it, we have to get rid of our first leading coefficient before we can do anything else. We can move the 7 first technically, but we're going to get rid of the 5 first. So we're going to divide 5 out of the entire equation. I can factor it out. I can write it as 5 times x squared plus 4x plus 7 over 5 equals 0. I just divided 5x squared by 5, 20x by 5, and 7 by 5. And unfortunately, I've got this fraction. I can now get rid of the 5 because it equals 0. And I'll just be left with x squared plus 4x plus 7 over 5 equals 0. And now we've got to complete the square. Move the 7 over 5 to the right by subtracting it. We're reversing the addition. X squared plus 4x equals negative 7 over 5. And now I need to figure out what do I add to both sides in order to complete the square. We'll do it in a different color. B in this question is 4. 4 over 2 squared equals 2 squared, which is 4. So I have to add 4 to both sides. Plus 4, plus 4. Now, the left-hand side of the equation is a perfect square trinomial. This is going to factor into x plus 2. And I know that because 2 times 2 is 4, and 2x plus 2x is 4. The left or the right-hand side is going to have to be left as a bit of a fraction for the time being. So we've got to join these fractions together. Minus 7 over 5. And then 4 needs to be written with a denominator of 5. I can write it as 20 over 5. Okay. At this point, we can join the right-hand side together. So x plus 2 all squared equals 13 over 5. I can take the square root of both sides. X plus 2 equals the square root of 13 over 5. If this was a perfect square, I could turn it into a whole number, but it's not. And now I can move the 2 to the other side. X equals plus or minus root 13 over 5 minus 2. And now technically the question wants the answer in decimals. This would be fine as the answer for many questions, but it specifically says to 2 decimal places and also has exact values. This is our exact value right here. If we want to turn these into decimals, well, we can just punch it into a calculator. So x would equal negative 2.45. Or if we did it with a plus, x would equal negative 1.55. So those are our other possible options. Technically, these answers are the same as our exact value in here, but it's just how the question has been asked. All right, on your own. Thought about this just a little while ago, and while you're doing these notes, if you have them in front of you and you're watching the video, pause it, and then you can do the on your own questions on your own, unpause it, and then see how I do them. So we're completing the square. We need to move the 3 over. X squared minus 10x equals negative 3. We then have to complete the square. In this question, b equals 10. So 10 over 2 all squared is going to equal 25. So we're going to add 25 to both sides. We've now got a perfect square on the left. This will turn into x minus 5 squared. And the right-hand side will be 25 minus 3, or 22. We can then take the square root. X minus 5 equals the square root of 22. And we can add 5 to both sides. X equals plus or minus root 22 plus 5. Why not simply factor the last equation? So that's saying when we get up to this point, why don't we just factor it? And there's a good answer for that. It's because it's not always possible. Not always possible. So when we're not able to factor it, we're stuck completing the square, and it's really our only option. We may need to simplify the radicals with exact answers. So for example, the square root of 60 could be written as the square root of 15 times 4. So it could actually be written as 2 root 15. So if we get ugly square roots, unfortunately, we might have to actually write them as mixed radicals. All right, solve and leave in simplest radical form. So x squared equals 20x minus 4. We want to move everything except for the 4 over to the left-hand side. X squared minus 20x equals negative 4. We then need to figure out what to add to both sides to complete the square. So negative 20 is b in this question. So you go negative 20 over 2, all squared, and that's going to be 100. So we've got to add 100 to both sides. Oops. So now x squared minus 20x plus 100 equals 96. This side of the equation is a perfect square trinomial, and it can be written as x squared minus 10. Or sorry, x minus 10 squared equals 96. We then have to go ahead and we have to take the square root of both sides. X minus 10 equals the square root of 96. And we have to see if we can simplify root 96. It turns out it can be written as 4 root 6. So x minus 10 equals plus or minus 4 root 6. We can then move the 10 over by adding it, and x will equal 10 plus or minus 4 root 6 would be our final answer. All right, one more, or actually 2 more. This one's a little bit uglier because we've got this 3, and we have to deal with it, so we've got to divide it out. If we divide the 3 away, we'll move the 2 over first, I guess. So 3x squared minus 6x plus 2 equals 0. We can pull the 3 out. X squared minus 2x plus 2/3 equals 0. We can then cancel out the 3 because it equals 0. We're essentially dividing by 3, but 0 divided by 3 is still 0. And then we can finish this off. We can move the 2/3 back over. X squared minus 2x equals negative 2/3. We have to complete the square. In this question, b is negative 2, so negative 2 over 2 all squared is just 1. So we've got to add 1 to both sides. The left-hand side is a perfect square. It's going to be x minus 1 squared. But the right-hand side, we've got to deal with adding some fractions. minus 2/3 plus 1 can be written as 3/3. And we'll be left with x minus 1 all squared equals 1/3. We then can go and take the square root of both sides. X minus 1 equals the square root of 1/3. And we can add 1 to both sides. X equals 1 plus or minus root 1/3. Technically, we could give this decimal answers. I don't know whether the question solve and leave in simplest radical form. So this is about as simplified as we can get it. All right, one more question and we're done. So we've got to deal with our 1/2 first. We're going to divide it out, and technically this should equal 0. We're going to divide it out, 1/2 bracket, x squared plus, and now 6 divided by 1/2 actually doubles it to 12. And then 1 divided by 1/2 again is going to actually double it to 2. And that's minus 2. And our 1/2, we can divide it away and get rid of it. So we'll be left with x squared plus 12x minus 2 equals 0. We can now move the 2 over, add it to both sides. X squared plus 12x equals 2. We've got to figure out what to add to complete the square. So in this case, b is 12. 12 over 2 all squared is like 6 squared with 36. So plus 36. X squared plus 12x plus 36 can be written as x plus 6 all squared equals 2 plus 36 is 38. All right, we're almost there. Take the square root of 38. X plus 6 equals root 38. Move the 6 over by subtracting it. X equals negative 6 plus or minus root 38. Last thing we have to do is double check. Can 38 be reduced? Can we reduce this radical into a mixed radical? And the way to test that is divide it by perfect squares. Divide it by 4. Doesn't work. Divide it by 9. Doesn't work. Divide it by 16. Doesn't work. And then after that, we're, unless it divides by 25, this is as far as we can go. This is our answer. So today we talked about completing the square. It's a technique used to solve these equations by hand when they don't factor nicely. The idea is you rearrange everything so that your constant term is alone by itself. You look at b, you divide it by 2 and square it, and you add that number to both sides. That will turn the left-hand side into a perfect square, which you can then factor, and then you can go ahead and square root the right-hand side to solve for x. I've got some questions for you. It's out of your workbook, page 222. Questions 4 to 10. Those questions that do have multiple options, just do A and C. There are some questions that only have one thing to do, so just do the question. All right. So I'm going to end the notes now. I'll post this on my YouTube channel, and I hope to see everybody in our Zoom session tomorrow. Bye.